Pete Giuliano. It is Friday, the 10th of November, 2023. Pete, what number is this?
SolderSmoke 249,
249.
249. Crank it
249
in,
is
Robert. Crank it in, Ralph.
crank it in, fellas. The show is on the road. All right. First, I got to say, first, Pete, the first thing I want to say today on Veterans Day is Happy Veterans Day to you.
Yes.
Happy Veterans Day to Grayson and to all the other veterans who are listening in today. Happy Veterans Day, guys.
And it's another important day.
What's that?
Marine Corps birthday.
It's the Marine Corps birthday.
Semper Fi.
Semper Fi, yes. You know, we when I was overseas at the embassies, this birthday was always marked by the Marine Corps Ball,
Yes.
which was an important event in embassy life. And Elisa and I attended the Marine Corps Ball at several times, different places around the world. Always really nice. The youngest Marine and the oldest Marine would come out and cut the cake. We did a lot at the War College too, several years at the War College. So really good. Happy Veterans Day, Pete.
Yes.
Hey, sort of apropos of that, in a kind of weird way, I just came back from San Francisco. I was out there on the left coast, on your left coast, Pete. I was out there.
Did you run into Gay Spiegelman or Yvonne Darger?
No, I did not run into any of those people who Pete has memories of. fond memories. Maybe we'll just leave it at that. He has memories of these people, we'll just say.
Entertainers.
They were entertaining San Francisco back in the day.
North Beach.
Anyway, but you know, I did a ham radio activity while I was out there. We went out to visit my daughter who's living out there now. And it's really a beautiful city. I mean, what amazing geography on the peninsula there, on the bay. Holy cow, it was really spectacular. But we took the opportunity to go out and put a sticker, a SolderSmoke sticker. You know, if you know stuff, you can do stuff. I had one in my pocket, and I said at one point, as we were moving around, I said, I want to put this sticker on the corner of Haight and Ashbury, because you guys who are old enough to remember Haight-Ashbury. I remember as a kid growing up, Haight-Ashbury, it was San Francisco just seemed so far away and kind of in another universe. But whenever I heard it, I heard about Haight-Ashbury. That seemed to be like the epicenter of hippiness in the 1960s. So Elisa and I were wandering around one morning while Maria was working, and we came upon Haight Street. I didn't make it to Ashbury, but the next day, Maria took us to the corner of Haight-Ashbury, where I found a post, and I put the sticker up on the post at the corner of Haight-Ashbury right there. So our sticker is now at the epicenter of hippiedom. I have a picture of the thing down below. Anybody wants to take a look, you can see the sticker. And Pete, you noticed immediately that there's another sticker on the post there.
Yes. Mushrooms. Magic mushrooms.
We're not advocating mushroom thing. It just happened to be on the sticker, on the post right there.
You live in San Francisco. Hey, you know, that was a strange time. I lived there in 1967. And one of the most interesting things that you had to experience is if you went to a grocery store that had like a meat market, the meat counter was closed after 6 o'clock. It was a union thing. You could only buy packaged meat. I mean, if you wanted a fresh cut of something, you better get there before 6 o'clock. I mean, I said, how could a big city like this have? But it was a union thing.
It's different. It's different.
Did you have any sourdough bread while you were there?
You know, we went to a place where they were making sourdough, but they were in the process of making it. But it was kind of cool because we went into this like bakery, a famous bakery in San Francisco. And as we were sitting there waiting for our breakfast, the guy was making the sourdough there. But I didn't get a chance to sample it, but that'll be on the next trip, Pete. Don't worry.
Yeah, they call those pasticceria. Pasticceria.
Oh, really?
Pastry shop. Pasticceria.
Yeah, really sounds very Italian there too, pasticceria. Yes. Yeah. Really, but a great trip, good all around. Hey, also on Travelogue, I want to make note of something that I came across in the course of discussing the double sideband rig that we've been talking about coming out of Cuba. A Cuban phrase that I think is really important that we want to incorporate into the lexicon. and that is cacharreo, which I looked it up because I had never really heard this term before, or maybe I had, but I've forgotten. But it means basically tinkering, taking
Oh,
something that's old and making it useful in a new way, or repurposing an item. You know, what we do here,
yeah,
Pete.
yeah.
And the Cubans have come up with their own term for it called cacharreo. And I think that this is something that we should definitely incorporate into the SolderSmoke lexicon. Attention there, Steve Silverman, our lexicographer. And I got a link to this whole thing. It all started with an article about Andy, CO2AFV, down there in Cuba, who has been home brewing kind of solid state versions of the DSB rig, which I think is really, really interesting. Solid state versions of, I think, the Islander rig like that. So pretty cool stuff. And check that out. That's another element of Travelogue we have. We haven't been to Cuba, but man, the knack is definitely existent on that island. Hey, one other thing, Peter, I wanted to mention, a couple other things. I have joined the DX Century Club,
Oh,
DXCC.
oh,
I know you're mightily impressed. I know.
oh.
Look, the problem here, it's the kind of paper chase and kind of awards thing that I usually, and I know you usually kind of steer clear of. But I decided to do the DXCC thing only because I wanted to do it as a kid and never made it. But now I decided, okay, I'm going to try to do it. But I tried as soon as I put up the hex beam, I said, okay, game on. All right. So we're only going to do it with the hex beam, and we're only going to do it with homebrew sideband rigs. So homebrew phone, no FT8, no digital stuff, no homebrew phone on the hex beam. And I guess it just took me a few months to get it, but it probably took me about a year to get all the confirmations. Now, these days, it's a lot easier. You don't have to
Oh
actually
yeah.
wait for the physical card to come in. It's nice to get some of the physical cards, and I got some of them, which is great fun. But the vast majority of the contacts were confirmed by a logbook of the world, LOTW, which seems to be a pretty good system. Anyway, I've got it done. I'm not doing any more awards, no more QSL card collecting or anything like that. But it was kind of fun, and I'm looking forward to having the. I wish they would put a homebrew endorsement on it. I think they'll only put phone or something like that, but that's okay. Better than FT8, you know.
Well, it's one of those cocktail party phrase droppers. Oh yeah, I made DXCC with homebrew gear and a beam running zero point 0.1 kilowatt, right?
Point one kW. Yeah,
Point
yeah,
one kW. There you go.
yeah. Hey, listen,
Cocktail
there was
party
another.
talk.
Pete, you're the one who has brought us a tribal knowledge, but there's a corollary to tribal knowledge, and it's called, and you've dispensed a lot of this yourself, tribal wisdom. And that's sort of big picture stuff. Tribal knowledge is more kind of narrowly focused on individual circuits or the use of certain components. But tribal wisdom is sort of the big picture, like the value of home brewing, the value of doing what we do. And just this week, I came across a good example of tribal wisdom, and it comes from a guy who's got a lot of tribal knowledge and a lot of tribal wisdom, and that's Rex, W1REX.
Oh yeah.
This is a QRP me guy, and he has done all kinds of stuff. I ran into Rex at a Hamfest years ago, and he had with him one of the original Tuna Tin 2s
Wow.
in a can. And he and I were joking about how much mojo is contained inside that Tuna Tin 2. A lot of mojo. And I arranged for a mojo transfer ceremony in which some of the mojo of the original Tuna Tin 2 would be transferred to the BitX 17 transceiver that I had built. And we did it by connecting the RF input line and anyway, the mojo was transferred. And anyway, Rex was interviewed by the folks out there at Ham Radio Workbench, George Zaff, and the others. They interviewed Rex, and man, he told some really great stories. He told a story about setting up a portable outhouse at the Dayton
Who?
Hamvention. At the Dayton Hamvention.
Oh yeah, 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 yeah.
So he set up the outhouse, and he put inside the outhouse a little shortwave receiver with a BFO. key that you got the BFO. And then he seated himself not far away, but close enough to see the call signs on the hams who were walking past the outhouse. And as they approached, he had a little CW transmitter in his pocket, and he transmitted their call sign, you know, K6CC, K6CC. This is W1REXK in CW. And he noticed how many of them would stop, like look into the outhouse. I knew this would appeal to you. You're the guy with the TV fuzzbuster with it. Anyway, I had the link up on the page. Check it out. The interview with W1REX is really, really good. Great stuff. Pete, time for your bench. What's on? You got a lot of stuff on your bench. I'm so happy to see that you got projects going.
Yeah. Well, it all starts with a failure. And a lot of this work on my bench now was a result of a failure. The computer on my CNC machine died.
Ugh.
Computer died. And so I said, oh my God, it's over. When that computer died, it's over.
The end of an era.
End of an era. So it was the motherboard and not the hard drive. So what I did is I took the hard drive out, and it had Windows XP Pro on it, and I installed it in a Windows 10 machine as a second drive, not to be the operating system, but I got access to all the files, so I didn't lose the files. So sometimes if you have a computer motherboard that dies and you've got the hard drive, you can make it a second drive in another computer and you not lose the files.
Well,
so I had to buy a new hard drive, and then I bought a new motherboard, and then I had to buy a copy of XP Pro because I can't find mine because the CNC machine only operates off of XP Pro, not with Windows 10. So I got that working, got everything going there, and it was kind of exciting. And first off, my son built the machine. He built the interface, and he installed the software on the computer. So I had to talk with him a bit, number 3 son. So at the end, when I got everything working, he says, you know what? He said, I have a job opening. I'd probably hire you. you could do that. He said, I'd probably hire you. So I said, thanks. So then I built another machine, another Windows 10 machine. Actually, I had Linux on it, and I built another Windows 10 machine, and I got my Homebrew SDR working. And then I added a second band to my, it was originally just 20 meters. So now I have a 2040 SDR running off of Windows 10 with Power SDR. Power SDR, you know, this goes back to our podcast on ICOM 7300. There's a guy, SV1EIA in Greece, who took Flex Radio Power SDR, and he modified the software so he could use it with Homebrew SDR radios. So it's really nice. You've got all the functionality of the Flex software, the original Flex software, not the stuff they're using today, but with the SDR 1000. But he made it so you could access it. So there's a guy that got into the software, Bill.
There you go.
Finally, guy got into the software. So now you can take just a Homebrew radio. It'll recognize that it's a Homebrew radio. Got that working. So I got that piece working. And then something else.
What did you have to do, Pete? What did you have to do to add 40? Did you have to add bandpass filter?
Yes. Okay. It's a relay switch bandpass filter. And that's an interesting 3-hour exercise and why something doesn't work. So I have a relay at this end, a relay at this end, and 2 bandpass filters. And so you power the relays, and it switches between the filters. What I didn't realize, the relays are polarized.
When you say they're polarized, you mean like the coil has a diode in there?
Yes.
Yes.
And the diode is in series, not across it, in series.
It's not a snubber.
So when I connected one up, it was right. And so I had them facing each other. So I just took the top terminal of each, but the top terminal was not the right terminal. And
so was it the relay wasn't clicking?
Relay wasn't clicking. It worked right.
It'd be deceptive because I know what you do at this point. You kind of put your ear close to the board and you see if the relay is clicking, right? Now, if one of them is clicking, you'd be fooled and you'd think, well, both of them are clicking.
Yes.
But they're not.
Yeah.
Oh, man.
Well, here's the thing. It was weird. It will work on one band. When the relays are not energized,
right,
it'll work on that band.
That's right. Yes.
would work on one of the bands, but we're working the other band. And I just said, so I thought a bad relay. So I put another relay in there and the same thing. And then the light bulb went on. I said, I bet you those are polarized relays. So then I had to swap the wires on one of the connections, and now they
You know, it's funny. We were just talking about this on the SolderSmoke blog, and I had put in there about using relays, I think, for pretty much the same purpose. And I just mentioned that, you know, I just, as a rule, anytime I put a relay in any of my circuits, I will put a diode and a cap across the coil. Now, we have had guys from the Vienna Wireless Society kind of scoff at that. Ha! All you need is one. Just put one anywhere in the radio and it'll take care of the whole thing.
Mm.
And I'm like, I don't know. First of all, I don't know about that. Second of all, what happens when I'm just testing it and I'm just using the one and I don't have a diode across it and the back EMF blows up all the circuitry in the radio? It's better safe than sorry. So I just put a 2-cent diode and a cap in there.
Yeah.
And Bob is my uncle.
Yeah, yeah.
But I mentioned this, and somebody else who was reading it came back and said, I don't think he really had focused before on the need for these kind of snubber diodes. And he said, well, why don't they just put the diodes inside the circuit? And what you describe is not really a snubber. It's kind of close. It's just kind of reverse polarity protection.
Yeah.
But you'd still need the snubber there, right?
Yes, I did.
Yes, you would. Yeah.
Yeah, I did. So they both got snubbers in both ends. So then when I built the low pass filter using the W3NQ and same relay switching, but this time I remembered they're polarized relays, and you gotta make sure you put the right connection when they were facing each other. I said, okay, the top connection this, top connection this. No, I had to go crisscross.
There you go, ladies and gentlemen. Tribal knowledge being imparted by Pete Giuliano. There you go.
So the next project I work on, if you look behind me, as I took the shirt pocket transceiver, and what I did is I added the Digi VFO and that sort of thing, and there's the real device right here in my hand.
Wow, man, very cool. I can see it.
It got the little display on it, and
I got a picture. I got a picture of it up on the blog page for the podcast.
Yeah.
But there it is. It's good to see it in video.
Yeah. So these little displays, I just bought a couple more, $2.58.
These are the OLED displays, right?
Yes, $2.58, 65,000 colors.
Yeah.
So really nice, really makes it work nice. So working on that. So now I had to order some parts from China for the tube rig. So I'm back working on the 6BA6. 6BA6 transceiver.
Because you're going to do all 6BA6 transceivers.
All 6BA6. So
Grayson loves it because all thermotrons.
Yes. I built the audio amplifier stage, and just yesterday, and up on my blog is a picture of the driver stage, and then the final stage is going to be, I'll get to that maybe today, maybe tomorrow. So then what I have is a solid state transceiver exciter package, so I can provide a low level single sideband into this stage and test it. So the view here is I have a known working single sideband transceiver at the low level stage, and then I'll feed that into the power amplifier. So this way, the only thing I have to worry about is getting the power amplifier to work, not trying to get the whole radio to work. I've got something that works.
The whole thing will eventually be a hybrid with solid state.
No. The whole thing will be all tubes.
Okay, so you're just using the solid state rig as a test base.
Yes. So then the next thing beyond that, once I get that working, I'm going to take the LM380 audio amplifier out, and I already built the 6BA6 audio amplifier, so I'll put that on there.
Oh man, so this is great. So you're going. It's like a time machine, Pete. You're going back into the 1970s, 60s, maybe the 60s. Yeah. Yes. All right. Yeah. I like it.
And but I'm using something that I know works.
Okay.
Instead of trying to say, okay, I got all this parts here and it doesn't work. Where's the problem? I know kind of a critical piece, so I'm taking one module at a time and getting that to work. And then later on, I'll take the ADE1, disconnect the ADE1, and put a 6BA6 product detector.
Oh, man.
So this way, you use that as a development process. So this way, I know that works. So now, why isn't this working? And you get everything to work.
Now, Pete, I don't want to be snarky here, and I don't mean to
Yes.
be, but there may be an element of snark here. Are you going to use the same process with the SDR architecture?
Like, how would I do that?
That would be rough. There'd be a lot of 6BA6s in there, man.
Yeah, yeah, yeah. How would I do that? Yeah, that's a lot.
I'm just kidding around a little bit.
Actually, now that you mention it,
Uh-oh, here we go.
my SDR is just two ADE1s. So if I had two bidirectional 6BA6s, they could do it. Yes, that would work.
But it'd be rough to try to replicate that FPGA in 6BA6s.
Yeah.
I understand that might be a bit difficult, but that is really cool. I have a preference for that kind of construction that you're doing, the 6BA6 construction, and you're taking it to a higher level because you're even going past. You're saying, well, I don't really like the discrete transistor element. I want to go back to discrete thermotrons, which I'm sure, like I said, this is a Veterans Day gift for Grayson.
Yeah, well, the whole idea came from the Germans. During World War II, the German field radios had all the same tube in the sockets. Every tube, it was these kind of rudimentary field radios, kind of like a regen and a 1 or 2 tube transmitter. It was the same tube in each socket, and you lift the case lid, and there's one spare tube in there. So their idea was that tube would work in any socket. So I said,
this always reminds me of like the Mate for the Mighty Midget receiver, the tube type receiver that used 6U8 tubes, 6U8s. 6U8s were a dual triode pentode. So actually you're getting 6 tubes for the price of 3.
Yeah.
But then we were looking at this and we discovered that the 6U8s, and Grayson was the one who kind of alerted us to this, they do not age well.
6EA8.
Right? So you just replace it with a 6EA8. And I bought a bunch of them, I think, from Antique Electronic Supply or someplace else. I popped them in there, and bam, the performance of the Mate for the Mighty Midget went right up. So that was a good move. But wow, that's a really cool project. When do you think you're going to be finished with it?
Oh, it's going to take a long time because I build and then I got my duties. I go to the board and care facility in the morning and the afternoon. So I only got a little window between about 11 and 2:30.
Well, it's good because it imposes a certain amount of time discipline on you. You say, okay, I got this time slot. What am I going to do here? I remember this was the same kind of time pressure I faced when I was working. I would get up in the morning and I realized, man, I got an hour and then I got to head out to work. What am I going to do in this hour? I'm going to do one board. That's it. And so I would do it that way. So yeah, but it sounds like you're well on the way, and soon you'll have that 6BA6 rig behind you there, Pete.
One of the things I'm going to try to do once I get the power amplifier stage where the driver and the power amplifier, I want to put a TR relay in there. So I'm going to try to actually use it on the air with just that stage.
Yeah, whenever I put a TR relay in there, I have to very often I have to put a second relay in there to fire the 0.1 kW amplifier.
yeah.
So I have an amplifier key line. So I've got all my rigs rigged up so that when I hit the push to talk on the D104, it also keys the relay that turns on the amplifier because you can't have the amplifier running when you're on receive. Anyway, kind of cool. Great stuff, Pete. Really excellent stuff. Anything else on the bench?
No, but I do want to finish that 6BA6. I actually did this before with 6AK5s, and I got the receiver working, and then we involved in a move, and a ham friend of mine, I said, look, I haven't finished this. I just gave it to him. I regret I didn't do that because I was closer to getting the 6AK5 working versus starting off a fresh year with a 6BA6. But I bought 15 6BA6 tubes for $9, and they're all good.
Did you run through the tube tester?
Yeah, they're all good.
They're all good.
They're all good.
This might be one of those tubes that ages well.
Yeah.
Unlike the 6U8. Good. So excellent. So all right, Thermotrons on the march. Hey Pete, another thing that's on the march. We're back in business with the BEZOS bucks.
Oh, got it working again?
Got it working again. We have now entered into the Shameless Commerce division. And I remembered, listen, here was the problem. I had this cool little icon on the corner of the SolderSmoke page. And the deal was anytime anybody from SolderSmoke or wherever started their Amazon search on that little block, boom, cha-ching, Bezos sent us some money. And it was really great for a long time, but then it just sort of disappeared. I mean, the computer software guys at Amazon changed something around and it disappeared. And guys kept sending me messages saying it was there one day and not the next, or there in some parts of the world and not the next, or there under one browser but not the other one. And it was a real mess. So I kind of just gave up on it and figured it was too hard. But then I said, wait a second. There's got to be a way to crack this code. And so I started asking around. And a bunch of people came to my assistance, including Todd Carney out there on the in Portland, mostly DIY RF. And we started exploring what was going on, and we finally figured it out. Anyway, all Amazon wants you to do now is when you put one of these little icons up there, you have to advertise a specific product. Here's the kicker, though. The user of this little icon does not have to buy that specific product. Right? It's just an advertisement there. The key thing is there's a little search block. So you can put whatever you want in there, right? And search for it. And then if you buy it within a day, cha-ching, SolderSmoke gets a bit of money. So I would just urge everybody, anytime you're thinking about doing an Amazon purchase, use the link that I have up on the SolderSmoke blog, because that will then send us a few pennies from Bezos. It will help support the SolderSmoke blog and podcast effort.
If you bought a Maserati, how much you get?
Man, well, let's see. It would be like 5% of 35,000. Okay. So it'd be a few $1,000, man.
63,000.
That's right, 365,000, right?
Yeah,
so maybe 15 grand. Yeah. So buy that Maserati out there, guys, and SolderSmoke will get 15 grand. All right, excellent. Yeah. But you do see some people every once in a while buying some high-end stuff. I recommend everybody needs a spectrum analyzer, Pete, right?
Yes, $4,000.
Yeah, none of this tiny SA stuff. No, the real spectrum analyzer, the big one. Yes. Get one of those. You need one. Everybody needs one.
Yes.
Nick the Vic has one. Why don't you have one? How come I don't have one?
Yes.
Hey, listen, the other thing I want to mention here now that we're in the Shameless Commerce division is what's going on out there. We mentioned him just a moment ago with Todd in Portland, out in the Silicon Forest. The Silicon Forest of Oregon in Portland. He runs a company that he set up out there called Mostly DIY RF. We've been talking about it quite a bit. And the project that is of most interest to us is that he is coming out with a kit of your design, Pete, the P3ST. What does P3ST stands for?
Pete's Simple Single Sideband Transceiver.
Yeah, a PS3T. PS3T. The Pete's Simple Single Sideband Transceiver. All right. So Todd is putting together a really cool kit that is going to allow people who want to build this thing to do kind of one-stop shopping and get everything you need to put one of these things together. He tells me that he is confident that the PS3T will be released on the promised December 18th date. So Todd has many other kits available. Check out the website. I have the link up there on the SolderSmoke blog. It's mostly DIYRF.com. You can just click on the link on the blog. The other thing is he has a really neat newsletter that keeps people informed on things like when the PS3T kit will be out. And you could sign up and subscribe to the newsletter. I also have a link to that on the blog, but I recommend that you guys do that.
He's got something exciting coming out as a part of that transceiver. He's got this module, and the module has got the complete IF stage on it. It's got the first IF amplifier, second IF amplifier, and the crystal filter sandwich in between. It's a plug-in.
It's really pretty cool.
Yeah, so to me, if you're a home brewer, you can buy just that module and experiment to your heart's delight. I mean, if you want to use it in some other application, you just buy that module. You got everything there. I mean, it's just plug in. Right,
really good stuff, and a lot of great ideas from Todd out there in Portland. So please take a look at his website and grab one of those kits when they come out on December 18th, because all the cool kids will have one, Pete.
Oh yeah. That's right. I said, when I looked at it, I was so excited. I said, gee, I might buy a kit.
but then you'll have to complain about the design. You'll say, man, this design sucks. It doesn't work. And you'll say, wait a second, I designed it.
Yeah.
All right. Hey, listen, got to move over to my bench here, man. I got a lot of stuff going on here. I'm blessed with more time than you have at this point, Pete. So that's why I'm kind of doing a little bit more. I am retired now, so my time is more available, and my kids have moved to distant cities, so it's we go out and visit, but in the meantime, I'm here and I have time on my hands, so I got to build radios, So I told you a while back that I built the 1510 transceiver. It's got an IF at 25 megahertz. VFO runs around 3.3, 3.8. And on one side we add, one side we subtract, one side we get 10, one side we get 15. And so it's a pretty simple little dual bander. This is the third dual bander that I've worked. However, when I built it, I noticed kind of after a while, after the initial euphoria of, wow, it works. Holy cow, I can make contacts on 10 and 15 meters. I noticed that the tuning on one end of the capacitor dial was less than comfortable. He's chuckling. See, he's laughing. He knows. He's saying he's got the solution right behind him, right there.
No. Yeah, but this is like helicrafters. I could not understand for the life of me the SR-150, the SR-160, CW portion of the band. It's like this. Sideband portion of the up at the end is like this. I mean,
I know, but I thought you were gonna jab me with an SI 5351.
No. I just
rotary encoder.
I mean, but there's same thing with National, and Galaxy solved that problem.
Galaxy solved the problem, and Helicrafters solved the problem, and Drake solved the problem, because you get all these other rigs from the same era that don't have this kind of bunching up problem. All right. So if I look at the front panel of the Drake 2B receiver, the dial is completely linear. I mean, one turn of the dial at one end of the band is 10 kcs, and you go completely at the other end of the band, one turn of the dial is once again 10 kcs. It's a linear dial scale linearity, or dial spread linearity. But I noticed that with the VFO that I had thrown together for the 1510 rig, it was stable. It was really good, really nice and stable. But it was the dial scale was far from linear. So if I was at one end of the band, man, tuning would be very, very critical, because I would move the tuning dial just a little bit, and I would have like a massive frequency change. So it made it uncomfortable. At first, I thought that there was something wrong with the cap of the reduction drive. But then I started to measure things, and I realized, no, we're back in the bunching up problem, because tuning was pretty good at the other end of the tuning range. There it was fine. It was just at the one end of the range, it was really bunched up. So I remembered then how to take care of this, and that is to use a dial band spread arrangement. And there's a great kind of website out there that you can use, and I have it on the blog. I have the link to it. It's Dial Scale Linearity Spreading Out by a fellow named Bob. And Bob, let me get his name here. Hold on a second. I got him here. Let's see. Okay. Where is it here? George, email, HB, Bob Taylor, Krishnan. Okay. Bob Weaver, the dial band spread linearity. He's got a website called Electron Bunker, and it is a really useful website, because what you do with this thing, it's a calculator. You plug in the frequency range that you want to cover. You plug in the value for the coil that you're going to use. You plug in like the capacity for the rest of the circuit, like the feedback circuit capacitance, and plug that all in there. And then you also plug in the style of capacitor, a variable capacitor that you're using. There's one style called midline centerline. There's another one called straight frequency capacitance, right? Straight capacitance, straight capacitance, not just straight capacitance. You plug that all in, And then it gives you a little display that shows you exactly what the linearity of the dial will be under those circumstances. So I went ahead and plugged in the components that I had used for the original VFO on the 1510 rig. And sure enough, it showed it all bunched up. Then I said, okay, let me use Bob's calculator, and I'll play around a little bit with the coil values, and I'll play a little bit about, and this is critical, with the padding capacitor that's in series with your variable cap, and what he calls the trimmer, which is another capacitor in parallel with your variable cap. And I plugged that in. And just by fiddling with it a little bit, I was able to cure the bunching up problem and get a linear dial spread, band spread, dial spread linearity out of the whole thing. So basically, I had reproduced what Galaxy and Hallicrafters and Heathkit had done, but with the other manufacturer that you mentioned, who failed back in the 50s?
Actually, it was Hallicrafters. The
How-
SR-160 was national.
Yeah, the
At the same point.
the HT37 transmitter is quite linear.
But the SR-160 and 150 has that problem.
Yeah, and you also see the problem in the really cheap like S38E, you know, or even the receiver that I used as a novice, the Lafayette HA600. The problem was that 40-meter CW band would be about that wide, right? And to get contacts in there was not for the faint of heart. But anyway, so then what I did, and this is something that you recommend a lot. So I got this design, the parameters for Bob Weaver's improved 1510 VFO using his website. But before I actually built it, I went to LT Spice and I built the entire VFO in LT Spice. And then I just looked and I could get it oscillating in LT Spice, which is pretty cool. But then I said, okay, set the capacitor at one end of the dial at 9 picofarads. What frequencies am I getting out? Then move it over to 150. What frequency am I getting out? That gives you the frequency range. The frequency range was right. So I could tell I was in the right frequency range. Then I could fool around with a little bit and say, okay, if I just move it a little bit, if I move it, say, 10 degrees on one end, what's the delta frequency? Move it 10 degrees on the other end, what's the delta? It looked about right. So I was pretty sure that I had sort of done what Bob's calculator recommended. And only at that point did I then go ahead and build it in the real world. I went over onto the bench and built one, and then was able to really physically power it up, put a frequency meter across it with the proper load. And then I made this little device where I could actually, with a little piece of cardboard, where I could just measure a 10-degree turn. And what does a 10-degree turn on the tuning knob look like?
Delta F for 10-degree turn.
Right. And I would do delta F for a 10-degree turn, and I did it all the way across the tuning range of the capacitor. And you know, it's not perfect because my measurement techniques are not perfect. I mean, I might be moving the thing 12 degrees and not 10 degrees, but it was clear that the bunching up problem had been resolved. And so then I put the thing into the rig. I have it in there now, and it is much easier to tune. And I could just tell that the dial scale linearity problem has been taken care of. So thanks a lot there, Bob Weaver, for that calculator from the Electron Bunker. I have links to it up there. And anybody who's thinking about building a rig like this, I really recommend it. It's worth the trouble to go through and see, all right, not just is the VFO going to be stable, but is the dial tuning going to be more or less linear so you can avoid this kind of bunching up problem?
Well, you know, that's really critical, Bill, because your actual VFO is in the 75 meter band, isn't it?
Yeah, that's right.
75 meter band.
Yeah.
So when you look at it in the 75 meter band, you'll have a lot of capacitance for the inductor. So the delta F that you make, delta C that you make, shouldn't change it a lot. It should be, I mean, if you built it at 15 megahertz, you just look at it, it'll jump 20 kilohertz.
Right.
So that effort is well worth it, because at that lower frequency, you should be able to get a more linear dial than you would, say, running it at a 15 megahertz.
Yeah,
15 megahertz would present some problems.
But what I discovered though, just fooling around with the calculator, was that there are kind of three critical elements that you have to keep in mind when you're trying to get dial scale linearity. One is the size of the coil. All right. So the size of the coil is going to determine the total capacitance that you need to get it resonant at whatever frequency you're operating on. So you got to play around a little bit with the size of the coil. And I found that I had to reduce the size of the coil. I started out with like 9 microhenries, but then I went down to about 3 microhenries, and it worked a lot better. I was able to get it linear. But the other two critical elements are the padding capacitor that you put in series with the variable capacitor, and the trimmer cap that you put across the capacitor, across the tuning capacitor. Now I got to say, I don't really fully understand why it is that you could take a capacitor that would by itself, if you just put it in there by itself with an appropriate value of inductor, would result in a lot of bunching up. Why, by reducing the inductor and by putting large values of trimmer and padder in there, you end up with a spread out, you crack the code on that. I have to play around and think about that a little bit more.
Product over the sum. You've got those two capacitors in series. It's
right.
like resistors in parallel.
Right.
And the product over the sum is going to change dramatically as you change those values. Like, for instance, if you got a 1 ohm resistor and a 10 ohm resistor, you essentially have a 1 ohm resistor.
Right.
Okay, so if you got a real small one and a real big one, but if you had like a 10 ohm and a 10 ohm, you got a 5 ohm. So the number is different. So
there you go.
That's changing. So you could plot that scale and use Excel to look at that difference. But the thing is, it's those two capacitors in series. One is a smaller value than the other, is it not?
Big time.
Yeah, so that's why you see that delta change in the bunching up.
Like the padder that I have there, the padder capacitor it's like 2,000 picofarads. The tuning capacitor goes from 9 to 150 picofarads.
Oh, 10 to 1.
Right.
Yeah.
Believe me, it spreads it out.
Yeah.
Actually, if you're not careful, you'll start to see it bunch at the other end.
Yeah.
Which is it's really interesting, but it's a really useful tool, and I strongly recommend it. This gets to us another thing, Pete. I've usually been building around 20 meters and 17 meters, but this is the first rig that I built for all the way up at 10 meters. And I just discovered that building at 10 meters is harder. You're on the border of VHF here. If you went from 10 to 6, you'd be in the VHF range. And it just means that, decoupling is more important, shielding is more important. Lead length is important, and everything else.
Critical, yeah.
I actually did a little calculation on this thing using LT Spice. I took just pieces of wire, and then I said, okay, let's pretend that these two pieces of wire, let's put them in LT Spice and call one the primary, one the secondary, right? And then measure the inductance of the wires, the two wires, plug that into LT Spice, but then take a signal generator and see how much gets across if you put, say, 14 megahertz through that wire, as opposed to 28 megahertz through that wire. And a lot more gets through at 28 megahertz.
Sure.
That's just something that's happening all the way through. This got me to the problem. I started noticing that my beloved EB63A 0.1 kW linear amplifier that I've been running so happily on 17 and 20 and on 40 was getting unstable at 10 meters. And, it was driving me nuts a little bit. Allison helped me out quite a bit. And I think we finally came to the conclusion was that I just had too much stuff crammed into one box. I had not only the amplifier, but in the same box, without a lot of proper shielding, I had all the low pass filters. So you had spotted a 10 tech low pass filter bank, and I got it. And at first I thought I was going to try to cram it in the same box, but then I said, wait a second, why am I doing that? So I built it in a completely different box with a completely different switch on it, and everything stabilized right away. Bob was my uncle, and so we got rid of that thing. But it's just a reminder that the 10 meters is harder. This got me with a 10 and 15 meter rig. I did something with this rig that I had not done, And because I began to suspect that not only did I have this problem with the amplifier, but because I'm using plywood boxes with no shielding, that it'd be pretty easy for RF from my antenna to make it back into the rig and start getting feedback and spurs and all kinds of ugly stuff. I have the tiny SA here, so sometimes I'd run the tiny SA, the spectrum analyzer, on the bench, and I could tell whether I was getting feedback through the rig or back through the amplifier. So I decided, okay, I'm gonna actually shield up this thing, and I kind of retrofitted. I bought some copper tape that Amazon sells. The cool thing about this copper tape is that the adhesive on the back of it is conductive. So if you overlay the tape, it's making one piece. So I did copper on all of, let's see, one, two, three, so 6 or 8 surfaces on the inside of this thing. And I put the whole box back together. And even though it's wooden, it's got an interconnected
Faraday
shell
shield.
yeah, it's like a shield there. And I think that helped quite a bit too. Although I'm continuing to violate the rules about shielding the VFO, Pete. All kinds of people will say, "Oh, the VFO has to be very carefully shielded." At one point, somebody said you have to get a hermetically sealed box, from Funk and Wagnall's porch or something like that. And no, when I look at all the VFOs from a lot of other rigs, I don't see that kind of fastidiousness, and it works fine.
I wanted to share something with you that I spotted. This I think his call is 4Z4GE, 4Z4GE. I think that's his call. Anyway, I spotted this Homebrew single sideband transmitter. Really nice looking outside of the case, very functional. You can tell this guy's got the knack. I mean, he built something. So then he lifted the lid off, and I looked at it, and I said, "Say what?" He had taken a bunch of Arc 5 surplus parts and built it into his transceiver. You could see the Arc 5 parts. But what he did is he cut down an Arc 5 receiver cabinet. The Arc 5s are kind of long.
Yeah.
He cut it down so it was only about 4 inches deep, and he kept all the gear mechanism and everything, but this was really shielded. I mean, he went through a lot of effort to cut down that chassis, but he said he has no problems with the VFO. And as a matter of fact, then he packed styrofoam around the Arc 5 case, temperature, keep the thing cool. He said that thing doesn't move.
Yeah, I mean, it's one of those things where I think, okay, theoretically, it'd probably be better, but when you look at the amount of effort that you have to put in to get, it's like building it at least doubles, I think, the construction effort. Whereas if you just take the thing and build it on a pine board, stage by stage, like I do, and it works just as well.
Well, you got to take a look at the other side of this thing. We do a lot of voltage regulation on our VFOs, 3-terminal regulators, or you use a Zener diode or what have you.
Yep.
The Collins PTOs have no voltage regulation on them.
Oof.
None.
Wow.
There's no voltage. And I say, how do they do that?
Why did they do that?
How do they do that? There's, matter of fact, but they did do, there was a mod to the KWM2 because they found when they were in Vietnam and using these, it would get like 130 during the day and 70 at night. That voltage swing was significant, so it was affecting it. So they did add 150 volt Zener diode on that, but most stock Collins PTOs do not have voltage regulation on them.
This reminds me of a problem that I was having when I first got back into ham radio, probably around 1993. I was in the Dominican Republic, and I was running my Hallicrafters HT37. And I would notice that I would go in there sometimes during the day, and I couldn't get it to go from T to R. I'd change this little switch on the front panel from transmit to receive, and I could tell the relays were just not firing. But then I noticed that this problem never happened at night.
Uh-oh.
The problem was that during the day, I was using electricity from the local power company, which the voltage might have been significantly down. It might have been down at like 100 volts, right?
Oh,
When I switched over to my generator at night, I was at 115 and the relay worked fine.
Jeez.
So, all right. So
Drive
there you
you
go.
nuts. Drive you nuts.
It will drive you nuts. Hey, a couple other things I just want to mention on the bench here. You know, one of the other things I did with a 1510 rig, and this was the result of a suggestion from our friend Farhan in India. I was looking at the bandpass filters, and I had started out using bandpass filters that were, but all of them were essentially kind of low pass bandpass filters. If you looked at the curve, they looked like low pass filters. But Farhan pointed out that with the scheme that I'm using, I need one of them to be low pass, but I need the other one basically to be high pass. So he recommended taking a look at high pass bandpass filters. And so what I did on the 1510 rig, especially for 10 meters, I came up with a high pass bandpass filter that is different. And I put it in there. It was an immediate effect. I noticed an immediate reduction in the number of spurs coming through. So I did a blog post on crushing spurs with better bandpass filters. And I thank you, Farhan, for the suggestion on that thing. One thing I wanted to mention, Pete, was that one of the things that goes on when you're doing all these kinds of changes is in rigs, for example, changing the BFO, the VFO. The old circuit that you pull out is like 90% there. So let me reach over here. Let me show you. So I have a couple of boards that are from like earlier. Let me put on my headphones here again. Earlier iterations of the rig, all right, of the 1510 rig. So for example, let me hold it up to the camera here. You guys can see it. This is a 10-pole crystal filter that I built. It's perfectly good, all right. I actually have marked on the back what I built. But I went with another one, but this one's perfectly fine. It's at the same frequency. It's at 25 megahertz. So that could go into a new version of the 1510 rig. And here's the original VFO circuit that I built.
A Tesla coil.
I know, it really looks cool there. It looks like I got a Tesla coil in there. It's just an old coil. But what I'll do is I'll rebuild this using, now look, the key element is the QF1.
Oh, another one bought the dust.
I know. I feel bad about it, but not that bad. But anyway, I'm going to take this thing and rebuild it so it's got the same dial spread linear characteristics of the new one. But the bottom line is that I have a box with like parts for the 1510 rig. I have another one. I see another one's in the works. I'm really enjoying 15 and 10 now that we're at this point in the sunspot cycle. Lots and lots of DX, especially on 15, on 10. Great stuff. So I might build another one there. Pete, can I tell you about the Hearing Aid 5?
Yes.
A sad story. This is a really sad story. I'll go through it right kind of quick because I've kind of obsessed with this thing. People have told me that I'm obsessing. All right. So I tried to build the Hearing Aid 5 receiver, which was the receiver companion to the Tuner Tin 2. The Hearing Aid 5 was in a QST in July 1976. I was 17 years old, and I really wanted to build a receiver. I thought all hams should build a receiver. I had never built one. This was the perfect thing because all the parts could be purchased from the local Radio Shack. There was no fancy variable capacitors. It was all Varactor tuned. I said, man, this is the receiver for me. I actually used ferric chloride and made the PC board that they recommended. And I really didn't know what I was doing. I saw this thing as like a blob of components. I couldn't see it in individual stages. I was new. I was a teenager. I was 17. I put the thing together and I could not get it to work. And it was really disheartening. And you know, back in the day, back when there was no internet, there was nobody I could really turn to for help. So I never got the thing working. 38 years later, I tried it again. And I was able, after 38 years, to get it to work. But it wasn't easy. I had the help of Dex, ZL2 DEX down in New Zealand, and he spotted that when I wound the coil, the transformer for the VFO, I put the proper number of turns on. I put it on the right spot on the base coil, on the choke that they were using, the solenoid choke, but I had wound it the wrong way, the wrong direction. The dials, the winding sense was wrong, which means that I wasn't introducing positive feedback to meet Barkhausen's criteria, but I was actually introducing, right. I was introducing negative feedback, and that's why the oscillator wouldn't work. So I yanked off the secondary coil, wound it the right way, boom, it worked. And I figured, okay, that was my problem. But this week, or this month, I got another email, a comment on a blog post on a YouTube video. Rick WD5L had also attempted to build the receiver, and he had failed. And he said that his failure was based on his placement of the FET used in the VFO. They have a VFO that was running off an FET, a Radio Shack part, but on the PC board diagram, they had you would plug the transistor in, and it would be drain, source, gate. The way the PC board was laid out, the source would go to ground, which is where you would want. You want the source at ground.
Gate was grounded.
But actually, if you use the part that you got from Radio Shack and you plugged it in that way, the gate was grounded, and the VFO, there's just no way it would work. So I said, "Oh man, that could have been a second showstopper." I mean, I definitely got the winding of the dial sense wrong, but I could have also, just like many other people, just plugged in the transistor and thought that it was okay. You know, I got emails from a number of guys who also, as teenagers, tried to build this thing and failed. And I'm talking about people who are pretty accomplished home brewers. Mike Bryce, WBAGVE.
Oh, yeah.
Kirk Kleinschmidt, he wrote to me. He worked at ARRL headquarters. He tried. How many others tried and failed to build this thing? There were other errors in it. I mean, really, showstopper, horrible, horrible errors. I never saw an errata. Nobody ever came out and said this was wrong. There was no, there were many subsequent articles from QST about rigs in the series. There was the CB slider, all this other stuff about building stuff on tuna cans and herring cans, all this other kind of stuff, but no errata on this stuff. And so anyway, I think we got it straightened out. And I finally, because I picked up a Hearing Aid 5 at a Hamfest earlier this year, and this allowed me to work on a Hearing Aid 5 as originally designed and built. And I went in there, and I could see that the guy who built this figured out the winding sense problem on the transformer for the VFO. So he got the VFO working. But another big problem they had is in the AF amplifier chain, they had a 10 microfarad cap to ground. 10 microfarad cap to ground in AF. This is going to take all the AF and dump it right to ground. So this thing, even if it's built as per the schematic, it's going to be
weak.
deaf as a doornail.
Yeah.
And sure enough, the guy who built this working Hearing Aid 5 that I picked up at the Hamfest had included the bad capacitor to ground. So he was good enough to fix the FET, but he wasn't good enough so he could spot an obvious schematic error in the QST article that was not corrected, by the way, by any form of errata. So we just kept finding more and more problems in it. Pete, what I came to a conclusion about this whole thing, and that is the direct conversion receivers that we're designing and building today are far superior to the Hearing Aid 5. Even if you got the Hearing Aid 5 completely squared away and took care of all these problems, it would still be a pretty poor receiver in all kinds of different ways. Whereas the one that Dean and I built for the high school students, far, far superior. And I actually did the test. I took my completely fixed Hearing Aid 5, put it on the bench and put it right next to the
Night and day.
The TJ, the DCRX that we built. Night and day. I mean, I don't even, George N2 APB up and in take another shot at the Hearing Aid 5. I was thinking, man, don't start over. Don't even try. It's just like, don't try to make a silk purse out of a sow's ear. It's not really worth it. The other thing I discovered, and I was reminded of this, the great benefit of our Manhattan style or dead bug style construction, because the Hearing Aid 5, it's built on a PC board, so you're constantly having to flip this damn board over. You want to change a part, you got to flip it over, unsolder the part, flip it back, pull the part out, put the new part in, flip it over, solder the part in. And you do that, 5 or 6 times and leads start breaking. It's just very uncomfortable. And I found myself yearning for our Manhattan dead bug style construction where everything is above the board and you could just go in there and boom, pull a part out. So Man, the Hearing Aid 5, ugh, thumbs down, thumbs down. But it's a reminder of how many of us were really kind of turned off by just terrible articles in QST, I have to say.
You're so right. As a matter of fact, I built a project out of QST, and if you built it, you could end up killing yourself. This was a 3CX800A7 linear amplifier, and I looked at the schematic and I says, "Boy, you build that, you're going to blow something up." So I found the author of the article, and he told me that they gave him the parts, he built it, he sent it to ARRL, they diddled with it, never let him check the final article, and they just published it.
Yeah.
And I said, "Well, what about this thing?" He said, "You're right." He says, you blow something up if you build it like it was in the article. So I guess not many guys built that amplifier, but I mean, you could have got electrocuted.
Well, yeah, I mean, I think a lot of people did build the Hearing Aid 5, and let me put out a call here because I have an unpublished blog post that is entitled Hearing Aid 5 Body Count. How many of you guys tried to build a Hearing Aid 5 back in the day and failed? Or how many of you guys tried to build it and figured out what the problems were and got it working? Please send me an email. Let me know, because I will add your project to the body count figures, which are quite good. Pete, the other thing this reminded me of is the great benefit that we enjoy today because of the internet and the World Wide Web. I mean, so a project like the Hearing Aid 5 could come out in July 1976, have all kinds of problems in it. And if nobody at ARRL or QST bothered to put out an errata, thousands of people all over the world are kind of stuck with this thing, and nobody can figure out why. Everybody builds it and thinks, oh man, I must be a terrible builder. I can't get this simple receiver to work. It's in the novice column of QST, for God's sake. Well, it must be me. It's not me, it's them. It's the article,
Yes,
right?
yes.
But nowadays, with email and instant feedback, Dean and I discovered this. We would discover a change, usually a change that I had made in the schematic, and then, oh yeah, we better tell the students about that. So boom, a couple of keystrokes, everybody knows how it's changed, right? And so, and if somebody runs into problems and says, you and I get all the time, you get an email from somebody saying, I can't get this thing to work, help me. And we help them out, we get to move them along. But back in the day, you couldn't do that.
Yeah,
So
just no way to do that. Hey, I'm going to send you a email that Tony Fishbowl sent me yesterday. A guy built my version of the direct conversion receiver in the UK, and it's really nice looking. And the thing that caught my eye is he etched a Manhattan board. In other words, he made all the squares and he etched them. So this way you look at it and it's just nice 1/4 inch squares on this PC board, and he built things Manhattan style. So I mean, once you got the etching pattern,
why not?
you can keep redoing that. You'll see that. And
You
really,
can do it.
really
You can
cool
do it. But the benefit is it's all on the top, and you don't have to flip the thing over every time you solder something in. Yeah.
Yeah.
All right. Anyway, let us know if you built a Hearing Aid 5 or anything else. Hey, on a more positive note, books. I've been traveling around a lot, and I've been fortunate to have some books with me. First of all, I'd like to recommend the 3 books by Basil Mahone. What a great name! What a great name, Basil Mahone. Man, that's a cool name. But he and a cool name with 3 great books about the history of radio. The one I'm reading right now is about Faraday. His first book is, I got it over here, The Man Who Changed Everything, about about Maxwell, James Clerk Maxwell. The earlier books deal with Maxwell's interactions with Faraday, and he has a 3rd book about Oliver Heaviside. But all of them deal with this kind of late 19th century, late 19th century period in radio development, in electronics development. Really well written. He is a former British Army officer, and he's got the writing skills and the technical knowledge to really describe very well what was going on with these great inventors, physicists, scientists, developers. Very often you'll find somebody who's got good writing skills, but you could tell that they just don't understand the technology, so the book is lacking, or vice versa. But Basil actually has both. He has both the technical understanding and the really, really great writing skills. So take a look at his books. I've got posts on all of his books up on the SolderSmoke blog. You can take a look at that.
Didn't he write that book with Linda Forbes?
He did. That was the second book. That was the book about Faraday and Maxwell.
Yes.
Our friend Armin down in Richmond, WA1UQO, sent me the first two books. Really, really great stuff. So I became a big Basil Mahone fan, and I recommend his books. Another book that came my way, and I found out about this guy, is Don Eyles. Don Eyles was a software programmer, one of the originals, and he wrote a book called Sunburst and Luminary, an Apollo memoir. He was, it's amazing, like a 24-year-old, 23-year-old, 24-year-old graduate in Boston, wandering around looking to find a job. He couldn't get a job with insurance companies. He was a math major. I think he had gone to BU or something like that, and he just happened to wander into the MIT instrumentation lab on a day that they were looking to hire somebody. Boom, they hired him. He became like one of the lead programmers, if not the lead programmer, on the lunar module that landed Neil Armstrong and all the other Apollo astronauts on the moon. And he gives a real candid description of how they did this using the technology of the day. Rope core memory. Rope. Holy, I mean, literally, they would call it, if they got a piece of software that they wanted to change, they would change it in the rope, and they would say, oh, it's in the rope. Wow. At one point they discovered an error in the Apollo 11 software just weeks before launch. And they figured, well, it's only a remote chance that the bug will happen. If it does happen, it'll be catastrophic. So they asked Neil Armstrong what to do about it. And Neil looked at them and said, fix it.
Yeah.
They literally had to climb up into the Saturn V to remove the box that contained that portion of the rope, rewire it, rewind through the ferrite cores so that the program would be as it was supposed to be. And that's what they flew. That's what they flew to the moon. So really, really great stuff. Finally, the book that I want to mention, and this is responsible for the T-shirt that you and I are both wearing. You and I are both wearing Transistor Man T-shirts. This is a book that I've been meaning to get for a long time, called The Art of Electronics by Horowitz and Hill. And somebody was talking about this. It might have been the IMSci guy was talking about it. I think it was the IMSci guy. And he mentioned that The Art of Electronics, the current version, is really expensive. However, if you go back and you get an earlier edition, they're far more reasonably priced. So I got the second edition of The Art of Electronics by Horowitz and Hill. Man, an amazing book. Really good. And Paul Horowitz is a ham. He was a ham as a kid. Still has his ham license. And he's got this very practical kind of no nonsense, not too much math, not too much theory, just enough that really makes it a great read and very illuminating. But he has in there, and this caught my eye. You'll see the T-shirt here. It's called Transistor Man, and it shows you basically how a transistor works in one little picture. This is a picture that actually appears in The Art of Electronics, and it has on it a formula too. It has the formula for HFE for transistor gain, and it just says I sub C equals HFE times I sub B. And what the transistor man is doing there, he's keeping an eye at I sub B, right? And basically whatever I sub B is, he is changing the value of the pot, the rheostat here, to permit more or less current to flow through there. And in a very kind of simple way, there you have HFE, right?
Yeah.
Now, I became aware of the T-shirt because Horowitz was being interviewed by Lady Ada, Lenore Freed, who runs that great company, Adafruit, in New York City. And during the interview, Lady Ada was wearing one of these T-shirts. And I just said, man, want one. I want one. They're not available anymore. But Roy, we're not going to mention specific because he doesn't want to get into the t-shirt business.
Business.
He made two of them, and he
Yeah.
sent one to Pete and one to me, and that's what we're wearing today. So we're wearing our Art of Electronics Transistor Man bling. Thank you for sending that, Roy. Really cool. Great t-shirts. Oh yeah, and another bling we have. Pete has his bling too. Pete has some Lamacan bling, and I do too. Move yours, Pete, a little bit because you got there. You go. You can see it, and I got mine there. The Lamacan Amateur Radio Club in Hyderabad, India. We are both honorary members, I think.
Yes.
I have other bling here. So let's talk about bling. I have the coffee mug that Dino sent me from Williamsburg from the radio club down there. And look, I have a jar, Pete. You might not have one of these. This is DIY marmalade.
Marmalade, yes.
Have you been eating it?
Yes.
Have you survived?
Yes.
All right. Well, I'm going to try it.
Yes.
All right. I'm only kidding. Thank you, Todd, for sending that out. Hey, listen, before we get to the mailbag, one other thing I wanted to mention, and that is test gear that we all have. So the tiny SA, the tiny spectrum analyzer, I mentioned it earlier that I kind of can fire it up and tell whether my signal is clean or dirty. It's kind of a cheap and easy way of doing that. But now they've come up with Tiny SA Ultra.
AliExpress.
Well, I tried to buy one from AliExpress. And I don't want to badmouth AliExpress. They have a lot of good stuff coming that way. But this, somehow, I kept checking the tracking, and the tracking kept showing it delivered. And I would go out to my front porch where all this stuff gets delivered, and there's nothing there. All right. So, but it was good because, it's no loss at all because I paid for it through PayPal. So I just went there and boom, canceled the transaction, and no money was lost. But then I went ahead and I still wanted a Tiny SA Ultra, and I bought it from the recommended vendor, and I got it. And man, it is a beautiful piece of gear. It's got a bigger screen. It feels more solid and everything else. And it's got a little plug. It's got an earplug in it. You don't have to modify anything. You plug in some earplugs and you can listen to whatever signal you've designated on the screen, which is fantastic. I could listen to 100.3 FM over here and AM signals and everything. Really great stuff. But anyway, so I got that. But listen, around the same time, a guy in the local radio club, George, WB5OYP, gave me a for real spectrum analyzer.
Ooh.
I mean, this thing's big. It's like microwave oven big. Okay.
Wow.
Now here's the device. It's the Polarad, not Polaroid, Polarad.
Yes.
Polarad 632C1.
Yeah.
It
Industry standard.
Yeah. But here's the thing. I can't find a manual with it, or I can't find a schematic or anything. I found one that was kind of close from a buddy of ours out there in Malta. He had it. He'd worked on it, but it wasn't really close enough. The problem is that there's a problem with one of the rotary encoders that it uses. It's got an optical rotary encoder that's obviously bad. But I don't even want to go in and start working on this thing until I have a good manual or at least a schematic for it. Does anyone have a manual or a schematic for the Polarad 632C1 or something that's close enough? I don't know. Maybe the version C2 would be okay. But anyway, check your.
Hey, I'll send you a link of a guy that works at MIT, and they may have that in the library somewhere.
I think that'd be great. That'd be really, really good.
Yeah. He writes us all the time. I just won't mention his call, but I'll send you an email, and you need to talk to him.
All right.
He probably can put his hands on it.
That'd be really cool. Send me the email, thanks. And if anybody else has any ideas, please let me know también. Also, I'm speaking Spanish. Hey, Pete, listen, mailbag. We got a lot of good stuff in the mailbag here, and I know we got to wrap this up because we're in overtime already, but it's okay. We got a lot of good stuff to talk. We mentioned the Transistor Man T-shirts. There we go. Thank you to Roy for sending those to us. I got really good email from Todd VE7BPO. All right.
Oh yeah.
And he sent me a nice email about audio frequency amplifiers and shortfalls and problems with audio frequency amplifiers. It's so great to hear from Todd. Todd is the longtime proprietor and
Popcorn.
manager of QRP Builder or Popcorn QRP.
Yeah.
All kinds of great stuff. An excellent engineer out there in British Columbia. Also got email from our old friend Wes, W7ZOI. And you know, Wes he's a very private guy, but it's really a privilege to be able to exchange email with Wes. When you realize, I mean, this is one of the giants of ham radio engineering, the guy who launched the solid state direct conversion revolution. And here we are, and I'm shooting emails and getting back and bouncing ideas off of him. He's very patient with me, and I just want to say it's always a privilege to exchange emails with
Solid
Wes.
state design for the radio amateur.
Solid state design for radio amateur, experimental methods in RF design, all kinds of books and articles over the years. I mean, great stuff. Similarly, it's also a privilege to be able to exchange email with Farhan, VU2ESE. I mentioned him earlier. I mean, he's the driving force behind the Lamacan Club, but somebody asked about his BitX 23, which is the VHF version of the BitX, and he responded to that, and we're working on getting information on that. Hey, listen, I'm not going to say anything else about this, but you know, the Hearing Aid 5. I said to myself, well, Jay Rushgrove, W1VD, he wrote the article, and I sent him an email. He responded, all right? But I don't want to say anything else about it. We'll just leave it at that. Hey, I got an email from Eamon Skelton, EI9
Ed. Yeah.
GQ. Ed, and you knew him. Pete, you knew everybody, all right? And we had been talking about him because we have his books. We have his Homebrew book, and we have his Build a Transceiver book. And so just on an off chance, I kind of looked around for an email for him, and I found it. And I shot him an email, and he sent back this really nice email. He mentioned you. He mentioned how he had compared notes with you over the years. What a great thing that we can be in touch with him. HB Homebrew to Homebrew. I mentioned on the blog a QSO that I had with Denny, VU2DGR, over there in Kerala, India. This is really great because Denny was running homebrew gear, including a tube type amplifier that he built.
Ooh.
And an SDR, a Raspberry SDR rig that he had built. But, you know, the amazing thing was just this morning, Pete, just as I was getting up this morning, I checked the DX spot page and I saw his call. He was on 20 meters this morning, but he was on 20 meters going long path. Ooh. Not over the North Pole, over the South Pole.
South Pole.
So I first put the beam on North Pole and I couldn't hear him at all. I swung it around to the South Pole and there he was. So I heard him this morning. I didn't work him this morning, but I heard him this morning. And it's always good to hear somebody that you know on the radio. Nick M0NTV, Nick the Vic, did a really great video on whether matching matters. He's talking about the diodes that go into our diode ring mixers. I think you and I express a little bit of skepticism about how much it matters, because sometimes you'll read these articles and guys will act like you have to go in there and match these things to the nth degree, you know? But then they don't seem to be paying as much attention to the transformers that go on either end.
Yes, it's the whole thing.
Or the Manhattan pads or the wire, or, you know, and then you very wisely put in a trim pot, even on the SBL1, right?
Yeah.
And so that was really cool. Anyway, Nick went ahead and he did the test. He carefully matched some diodes for a diode ring mixer. And then he built a second mixer, exactly the same, except using completely unmatched, randomly selected diodes. And he discovered that there was no real difference between the performance of the two. But take a look at Nick's video. I have a link up there on the blog. Paul Taylor wrote into both of us. Paul Taylor, another really amazing home brewer. He's down in Melbourne, Australia, VK3HN. He wrote to us about the new Elecraft CW rig. I don't know. I don't know what's going on there. I don't know. I haven't looked at it, so I don't want to say anything. I mean, I'm sure it's kind of going to be popular with the POTA guys, but I don't know. Might bear some scrutiny there. All right. I wish.
Yeah, it's kind of weird. It looks like a walkie-talkie, but the controls are on the bottom. So they got the the tuning and the volume and the paddle on the bottom, so you'd have to hold it in your left hand. I'm thinking, what do you do if you're what
I don't know.
if you're left-handed and you got to do it the other way?
I'm sure
But I
Wayne
mean, it's
Burdick
just
and Eric Schwartz have
I
some
mean,
good thoughts about it, but
I mean, it's a great concept, but it just to me, my ergonomics, I'd have a problem with my fat fingers.
yeah, I know, fat finger syndrome. Dean KK4DAS has actually cracked the code and fixed that old Helicrafters tube type
Yes,
receiver, and he stuck with it, man. He just there was a long hard battle, and he stuck in there, and he had a lot of help from you, me, and Grayson, but I think in the end he fixed it himself. And so hats off to you for a long battle, finally won. But also Dean has been recently home brewing crystal filters and been kind of consulting the literature on how best to do this. It's been a really good project for him. And in the course of doing that, he reached out and got emails from G3UUR himself, from Dave Gordon Smith. Um, and so it's just amazing. He was amazed that he got that kind of direct feedback from one of the people who's been in the forefront of measuring, emotional capacitance and emotional inductance inside crystals, so that you could use the software that's used to predict the values that you need to build around, say, a 10-pole crystal filter. I've had some really good email exchange with a longtime friend of the SolderSmoke podcast. That's Ramakrishnan, VU2JXN. And what he's doing is he's helping me come up with a backup version of the SolderSmoke blog. The SolderSmoke blog, we've been putting it out since like 2007. There's well more than 1,000 articles there, and I'm always kind of uneasy.
the computer dies.
Well,
What do you do?
no, Google decides to pull the plug or something, right?
Yeah.
Blogspot. It's happened. So anyway, we're looking at alternative sites, and we'll come up with, I think we've come up with a good plan to have a completely separate site paid for that we're going to be able to put the SolderSmoke blog on to make it a little bit less kind of endangered by the capriciousness of the Google folks sometimes. Mark KI9OOI noticed that in a similar subject, noticed that the SolderSmoke podcast archive appears to have gone. It's there. It's just been temporarily relocated. If you really need to look at the archive, just go soldersmoke.com.podcastarchive.html. And then we've just moved it temporarily. We heard from Andreas, DL1AJG.
Oh yeah.
He's the guy who
guy.
who is building the biologist, and he was working with direct conversion receivers with his biology students. He recently got into crystal radio too, and he sent me this really cool video about a guy who was building crystal radios, and so I have that up on the blog. I mentioned George N2APB. George had got involved in the Hearing Aid 5 because back around 1998, NorCal QRP redid the Hearing Aid 5, and they made improvements on it, but they included in the redesign the bad capacitor to ground. Oh God, I don't know. We heard from Grayson, KJ7UM, and Grayson has been experimenting with varactors and thermotrons. Very fine. Good luck to you on that, Grayson. And again, happy Veterans Day to you. Thomas, K4SWL, saw my post. I sent him my post on the direct conversion receiver that Mattia in northern Italy had made. Mattia built this thing back around 1996. Man, it is a piece of work. It is beautiful. The outside, the case, the socketry, everything is great. He even has a little analog meter that he uses as frequency readout. I thought that was very, very cool. And Matthias liked it, put it on his blog. I mean, Thomas liked it, put it on his blog, and a lot of people saw it, and I think got inspired by it.
He did a review of the Elecraft KH1, by the way. If you check his post.
What was his bottom line on it?
He liked it.
Oh, he liked it. Yeah. I mean, I think it's definitely something that's going to appeal to the POTA guys, and Thomas is definitely in that group. let's see, I mentioned Bob Weaver, dial spread linearity fame. Check out his website, The Electron Bunker. I have links on the blog. Mike Bryce, the BB8 VGE, is in the QRP Hall of Fame, and he
Yeah.
too couldn't get the Hearing Aid 5 to go when he was a kid, which makes me feel less bad about it. If Mike
He's the
Bryce can't do it,
He's the Heathkit guy.
yeah, he had the Heathkit store and
Yeah.
for a long time. He's also was big into the HW8 QRP Heathkit rig, and big into solar power too.
Yes.
He's been and a prolific and proficient home brewer. Again, a fellow member of the QRP Hall of Fame. And so if he had trouble with this rig as a kid, it makes me feel less bad about me having trouble with the rig. Somebody else who had trouble with the rig, as I mentioned, Kirk Kleinschmidt, NT0Z. He's a former ARRL staffer, and he also, as a kid, tried and failed to get the Hearing Aid 5 going way back when. I have an article on the blog about him too. Pete, 1 hour 25 minutes, man. You got anything else to add? You got anything else?
No, we're good. We're
We're good. Holy cow! I know you're very busy. Thanks for taking the time out. I'm sorry.
2 weeks from yesterday is Turkey Day.
I know it's coming up.
And I'm surprised you didn't mention anything about Mars in opposition. This is when you get your telescope out, isn't it?
No, not this year. There's a 2-year gap between oppositions.
Okay. So
the 2020 was really good. 2022 was not so good.
Next year
we got another year for Mars opposition.
Thanksgiving, right?
Thanksgiving. It's around Thanksgiving time. That's right. I will hopefully have the telescope set up in the Dominican Republic by that point, and we'll look at it that way. So yeah, but thanks for remembering, Pete. And Pete, thanks for taking the time out to share some tribal knowledge and tribal wisdom with us. It's always a pleasure.
You bet.
Take care now. 7-3 from Northern Virginia.
7-3 on the left coast.
7-3. Thanks a lot, Pete.
You bet.